Hello friends, welcome to my new channel. In this new series, I'll be lecturing about physics in general. This series only consists of my interpretation towards each class's physics concepts and my insight towards it. I'll be making this series more interesting by inculcating examples as and when required. Moreover, any constructive suggestions are always welcome. Having said this, I'll be starting with the first concept in physics, that is motion and time, which according to Indian curriculum of NCERT textbooks is the first concept to be understood by all future physicists as basics. And 7th standard is where the journey of physics begins with actual terminologies. Now let us start with the concept of motion and time. The first problem to deal with as per the title of the topic is to know what is motion and what is time. We see that every object around us are involved in some or the other kind of motion. Nothing is stagnant or stationary forever. Object sometimes seems stagnant at that moment, but it will be in motion at its own pace. To justify this, I would like to give you an example or an ideology which is outside 7th standard syllabus but is very easy and interesting. Consider this to be you, and there is a tree in front of you. For you, the tree is not moving, but it is moving very fast in this universe. The tree that you are seeing is on earth along with you. Now, as you know how shadows are formed, must be knowing that earth is rotating on its axis, causing day and night. So you and the tree both move as the earth rotates. Now, earth along with you and the tree revolves around the sun, and sun in turn revolves around the Milky Way galaxy. So you along with the tree are moving around the Milky Way galaxy. The Milky Way galaxy is moving in the universe. So you can consider yourself and the tree to move along with it too. That is why the tree which was stationary for you is actually moving very fast in the universe. Now that it is known that no object is stationary in the universe, if in higher classes you are asked to consider a stationary object, it just means that you as an observer is also moving along with that object. That is, the object is stationary to you and your surroundings, but not to the whole of the cosmos. Now that I have said that every object in the universe is in motion, so it becomes a necessity to understand what motion is all about. Primarily, to define motion, we require an idea of what object is and also should have an idea of what time is all about. The idea of time can be well understood by seeing a clock. And you yourself are the simplest object to imagine. Motion of an object is defined as the change in the position of the object with respect to time. By marking the keywords position and time, we can say motion involves a relation to both position and time. Here, position is a representative of space, and time itself is a representation of itself. A definition is nothing but the truth expressed in a short way. The explanation based on the definition can sometimes be proved wrong or can be changed with new theories. In the definition of motion, we can see that if any object is considered to be in motion or for any moving object, the truth is that the object should always change its position as time passes. And if only time passes and there is no change in the position of the object, then it is said to be stationary. Now let us dig deeper in understanding the way both space and time are involved in defining motion by taking some examples. I forgot to mention you earlier that to understand physics in a better and easy way, you must have a very good imagination. I also suggest the viewers to read the prescribed textbook once before or after hearing my interpretation. Now let's begin with some imagination. Consider yourself walking in a park near your house early in the morning. Many people are already taking their walk. You see people moving with various speeds. Some are moving fast, some others are moving slow. Here, fast and slow are relative to each other. It is relative because the fast moving person seems to move fast only when he is compared with a relatively slower moving person. And similarly, a slow moving person is relatively slow only when he is compared with a fast person. Now that I have given you an imagination of how fast and slow are relative to each other, relativity in simple sense is like fast is not fast until you have something slow with it. And similarly, slow is not slow until you have something fast to compare with it. If this point was something to deal with, fastness and slowness of the motion, now again imagine that the fast moving person gets tired over some time and suddenly starts walking slower than what he used to before. In such case, for you, the same person is found to move both fast and slow at two different times of your observation. Thus, we can say that the same object may move differently at different times. These examples can only be understood based on how well you imagine it. If you could not get to imagine it in one go, please do rewind and hear it once again till you get it. I'm making you imagine everything because I think depicting pictures and making you hear voices will only help you in registering things as the way it is. But imagination increases your creativity. Now for the third point, we will have another imagination and consider the slow moving person to be the only person in the park and no one else is there in the park. Then there is no way to judge the person's speed and to determine him to be slow or fast because we don't have anyone else there to compare his speed with. Like this, there are many examples to relate to motion in your daily routine. In all the three examples, fast and slow were only relative till now to understand due to comparison. But if we exactly measure how fast or how slow is the person actually moving, then his or her speed can be compared with any other person moving anywhere outside the park or wherever. And it can also act as a reference to even the same person on the next day at the park to compare as to how fast the person moved yesterday and how much is he moving with today. Thus, by comparison, we can only say about their relation with each other. But measurement of not only motion, any other quantity for that matter will always serve to be a reference and make it standardized. Now to standardize fastness or slowness, let us consider an example. Imagine that you are participating in a running race of 100 meters. When the whistle blows, you try very hard to reach the finish line first. But if you stay first throughout till the finish line, you would miss my point of view. But if you manage to be the runner up, you visualize that your friend who won the race managed to cover the 100-meter distance that you too covered in a lesser time. So we can say the person who covered a fixed distance with a relatively lesser time is faster. Now let us discuss about standardizing motion in another perspective. Consider that your friend who came first in the 100-meter race finished the race in 30 seconds and you had covered only 95 meters in that 30 seconds, which made you the runner-up. So we can now say that the person who ran a relatively longer distance over a fixed time is faster. Thus, from both the examples, we took two methods of standardizing motion. One by fixing distance for variable time and the other by fixing time for variable distance. among which the second method is most practically acceptable and it is also useful in comparing two quantities because we had mentioned earlier winner takes 100 meters in 30 seconds and the runner takes 95 meters in 30 seconds. It is easy to represent it like this. But if you are fixing the distance to be 100 meters and you are talking of winner, it is easy to represent as 100 meters for 30 seconds. But when you are talking about the runner, as you have fixed the distance to be 100 meters, so if you are calculating for 100 meters the time of the runner who had 95 meters when it was 30 seconds, so for 100 meters he will take 31.5 seconds or so, like that. So there is a difficulty in representing the units. So there is a difficulty. So we prefer the second method. Now, if you are asked to mention the characteristics of a fast moving object, you can say it is the object that takes less time to cover a fixed distance, or also as the object that covers longer distance in a fixed time. Similarly, the characteristics of a slow moving object is that it takes more time to cover a fixed distance, or you can also say that the object which covers shorter distance over a fixed time is slower. The quantity that I have represented here is called the speed. 100 meter per 30 second is the speed of the winner and 95 meter per 30 second is the speed of the runner. Now we will see what is speed and define it. Speed of the object is defined as the distance covered by the object in a unit time. In the earlier example, I had mentioned that the winner moved with the speed of 100 meter per second per 30 seconds. This was the speed of the winner. Now, if we extend his speed to 1 minute, we would have to multiply a factor of 2 to both numerator and denominator simultaneously. So then we'll get 200 meters per minute, where 30 seconds into 2 is a 60 second, which is nothing but 1 minute. This means that the winner travels 200 meters in 1 minute. This condition is only possible when the athlete covers 200 meters with constant speed. That is, when he follows a uniform motion, then only this condition is satisfied. Now, for the second possibility, let us suppose that the winner had covered 100 meters in 30 seconds for the first 30 seconds of the race. And due to tiredness, he only manages to cover only 80 meters in the next 30 seconds of the race, which makes him cover 100 plus 80 for a minute. So, making him a speed of 180 meters per minute, which is different than the earlier one. And it is lesser because of the tiredness that he felt during the race. This possibility of varying speeds that we saw, that is 100 meters for 30 seconds in the first half of the minute and 80 meters per 30 seconds in the second half of the minute, depicts a special case of non-uniform motion. That is, the motion was not uniform. In the first case, we observed same speed, that is 100 meter per 30 second, and another 100 meter per 30 second in both the halves of the 1 minute race. But in the second case, we observed two speeds in a single lap of a race, because of which, that is, two speeds are which of the 100 meter per 30 second for first half of the minute and 80 meters per 30 second for the second half of the minute, because of which we cannot use the term speed for the overall 1 minute of extension. Thus, to avoid this problem of variation in the type of motion, that is in particular non-uniform motion, we take average speed of the object as standard. Now, what is average speed? Average speed is defined as the total distance covered by the object in a total time interval. This is considered specifically in the case of non-uniform motion. This was the example that I had considered for non-uniform motion, wherein you had 100 meters in the first half of a minute and 80 meters in the second half of the minute. So whenever there is a non-uniform motion, there is two speeds for the same motion. So we just took a total of both the distance, that is the total distance, and we added up both the time interval, that is 30 seconds plus 30 seconds became a minute. So totally this is the average speed of the runner whenever he gets tired in the middle of a race. Now that I have mentioned cases both for uniform and non-uniform motion, I would like to end this video for now. In the next part, we will try to understand what is time and how to measure it, and many other such topics as per the textbook, with many more interesting examples. I would like to request the viewers to share the video to the needy students if you liked it, and press that like button. If you liked this video and get notified of many more videos of such kind, please do subscribe my channel and hit that bell icon along with the subscribe button. Thank you.